In this lesson, we're going to study what is essentially the intermediate value theorem's like big brother, and that is the mean value theorem. And to introduce this idea, we're going to consider something you've probably experienced in real life. This example is about driving with your Easy Pass on the tollway, but you could just as easily apply it to the speed cameras you see when you're driving around the city of Chicago. Usually there's ones by parks, right? And if you go over the speed limit through the park, they will snap a photo of your plate and you'll get a ticket in the mail. So actually, the math behind these speed cameras is 100% exactly the mean value theorem. So that's how we're going to introduce this idea. So again, we're considering somebody driving on the tollway and getting a speeding ticket based on their Easy Pass, like their tollway pass. So we're going to use these questions to kind of explore this idea a little bit. And what we'll see is it's really similar to the intermediate value theorem. How many hours does it take Leanne to make it from Rock Falls to Maple Park? Well, if we subtract these two numbers, we get 48 minutes, which is the same as 0.8 hours. And the reason that we are going to need that number is we want to know her average speed. So we have from Rock Falls to Maple Park, we have 55 miles divided by 0.8 hours, which is 68.75 miles per hour. Okay, and then notice we're given a speed limit of 70 miles per hour. And the question is it possible that she was speeding during that time period? So notice this language already starts to sound like the language we use with the intermediate value theorem. I would argue that yes, it is possible, because at some point she may have gone faster than her average. And notice I want to say may have gone because I don't have evidence that she definitely went faster than her average, because she could have gone 68.75 miles per hour constant the whole trip. And that actually answers question number 4, right? Do they have evidence that she was speeding, right? It's possible that she was speeding, but I would say no, that they don't have evidence here that she was speeding, because her speed may have been constant at this speed that's under the speed limit, right? And then now we're going to consider this second time interval. So it looks like it is a 29-minute trip, which gives us 0.483 hours. And then her average speed, well, she travels 40 miles. And I have kind of a bad feeling about this. Yep. This gives us 82.816 miles per hour. So now, here is where she gets her ticket, right? So I'd say yes, there absolutely is evidence here that she was speeding. And here is where they really get you, right? This is the theorem. And this is where the proof really gives you the evidence to convict somebody of speeding, right? So must there have been a moment where Leanne was driving exactly at her average speed? The answer here is yes. So her speed is an average, and she may have gone faster or slower than her average. And because speed is continuous, she can't just skip over this value, right? You can't go from 70 miles per hour to 90 miles per hour. You have to go all the speeds in between, at least for a little bit of time. So that's the theorem. And notice, like, we have to say that speed is continuous here, just like we did in intermediate value theorem. And really, you can think of this as intermediate value theorem for derivatives. The nice thing here is we've already studied a couple of these theorems, so you're really familiar with the idea of justification here. So in the next page, we're going to look into how to justify things with these theorems. Okay, we now have 3 theorems that we've used to analyze functions. There's the intermediate value theorem, which requires that a function is continuous. There's the extreme value theorem, which required a function to be continuous. And now the mean value theorem is essentially intermediate value theorem for derivatives. So we require a function to be continuous and also differentiable, right? So it doesn't make sense to talk about the function's rate of change unless that rate of change is well defined. Okay, so let's look at the formula for how to write these sentences, since we've now done a couple with intermediate value theorem. That's going to set us up for success to write a mean value theorem justification. Okay, so I want to just note we have 3 things to look for when we justify, right? The first is the conditions, right? And notice here we state that f is continuous, right? And again, here we state that f is continuous. And here we won't look at C for a second because C is an example of not using the theorem. So first we check our conditions, right? So we check that the function is continuous. And intermediate value theorem had that condition that the y value is between the others. So that's part of our conditions, right? Then we invoke the theorem, right? And the last thing we do, right, is we write our conclusion, right? And the order here doesn't matter so much. And notice here in this sentence, again, the order doesn't matter. We also restate the question, right? So the question is, determine whether the statement is valid. We say the statement is valid. Here is our conclusion. And notice, is there a number D? Here is the question restated in our conclusion as well. Okay, so just like we do in the humanities, it's good to restate the question in our answers, right? And then just here's a note, right? So we might think, as we look at this example, that the maximum is definitely negative 17. But it could be, or sorry, the minimum, that should say, right? But it could have a minimum that's negative 20 that we just don't see, right? So be careful not to go beyond the theorem where it helps us prove. Okay, let's look at a new example here. So here we're asked to determine the validity of the following statement, and the statement is there is a C in the interval negative 2, 1 such that f prime of C equals 4. Okay, so because we're dealing with a derivative right away, I know that this is a mean value theorem problem. And we're going to do the same thing as before. We're going to check our conditions. We're going to invoke the theorem. And then we're going to state our conclusion. And in doing so, we're going to restate the question. So mean value theorem had two conditions in our formulation on the previous page. That it's continuous, the function f, and the function f is differentiable. Don't worry too much about the closed interval, open interval parts. That's not going to affect our lives too much. So there's our conditions, our first condition. Our second condition is that there is an average rate of change equal to 4, right? And what I can see, if I do this here, average rate of change from negative 2 to negative 1 is 4, right? So I can say then, and f of negative 2 minus f of negative 1 over negative 2 minus negative 1 equals 4. So then I've stated my conditions. Then I can invoke the theorem. So by the mean value theorem is the theorem I'm using, and yes, you have to use the right one. And then I'm going to write my conclusion. And for bonus points, I can restate the question, right? So the question was determine the validity of the statement. The statement we proved was true. So we just proved that Leanne was speeding somewhere on negative 2, 1. And that's step 3. So here's a formulation you can use to write your sentences. So check your conditions, invoke the theorem, and then state your conclusion. And notice I'm restating the question in my conclusion.